Hello guys, welcome back to my lecture series of automotive design. So till the last video we have discussed about some of the concepts of automotive design, and we have discussed about some manufacturing process, and the most probably we have discussed about manufacturing process for plastic products. Okay, so yes, so right now we are discussing about the design requirements of a plastic product. Apart from this, we have seen one design requirement, that is a draft angle. So in the last video I have covered what is about a draft angle, and why it is mandatory, and why it is design requirement, and why we are keeping always 3 degree to 10 degree for draft angle for the plastic parts, and what happens if it is more than 10 degree, or if it is less than 10 degree. So all these type of questions I have answered in the last lecture. Okay, so I hope you guys are very clear about our draft angle now. So in this video, there are few more design requirements that we should keep in your mind before making a plastic product. Okay. So after that draft angle, you should keep the tooling axis is also your requirement. Okay. So the tooling axis, by the definition, you can clearly see that the direction from which the core and cavity will moves. Okay, so what does it means? Whenever you are specifying the tooling axis, so you're saying to the mold designer. So for example, uh, let's take one line. So when you are specifying tooling axis like this, so you are saying to the core and cavity designer. So your core and cavity, it is a cavity. Okay, and this will be the core, right? So you are specifying that these my tooling axis, and your core and your cavity should move along with this direction only. So that is what the meaning of the tooling axis. So read it again. What it is means the direction from which the core and cavity will move. Okay, so that is what the tooling axis means. Okay, so why it is that now you may have one question that, oh, that is what I have written here, because I also having the same question when I first time learning this topic. Okay, why it is design requirement even though you are not designing the core and cavity of the part? So for example, you are making the mid portion only. So the tooling axis is more relative to the core and cavity designer. Okay, that it is not a direct design requirement of plastic product designer, but it is a more contributes to the core and cavity designer. Okay, so this question, so I think you will be finding the answers by yourself at the end of this session. Okay. Now let's talk more about this tooling axis. Okay. See, for example, so okay. Let's talk about more about tooling axis. So okay, now you have clear about, okay, you have basic idea about what is tooling axis. Okay, now the question is, this question we can answer it at the end of this tutorial. Okay, okay. The next question you will be having is, how can we create a tooling axis? So the golden rule you should keep in your mind is, whenever you are making a tooling axis, an important factor is that the tooling axis must cover all the draft faces. So this is a golden rule that you should keep in your mind before making the tool axis, because there is no any direct feature in any software to make the tool axis. So what we do, we study the geometry of the part, and from the geometry itself we are specifying that tooling axis. Okay, so this is a important thumb rule Okay, you should keep in your mind. Now, what is a draft phase? You may have one more doubt, right? So last video I have seen about we are seen about the draft angle. So what does it mean? Some the plastic parts having the walls, slanted walls, right? Not like a straight walls. So that faces we can refer it as a draft faces, right? So here that is what the meaning of draft faces. Okay, so now what does it means by the tooling axis must covers all the draft faces. So what does it means that I will try to make one part. Okay, so this is my one of my plastic part. Okay, I want to make it. Okay, okay, then obviously I require to have one core. Okay, this is my core and this will be my cavity. Okay, so if you seen it from the top view, so how it may appears, let me draw that again. This is a box and top side. Okay, and in the bottom side it may seems like this, a 3D view, right? Let me make it clearly. So this is a top view. When you are seeing it from the top side, so what you may see, you are seeing this outer as a top one, and this will be your base. So this thing, right? So in this case what you're saying, you are specifying, I'll put one point here. So that means, okay, this is our point. Actually it is not point, which is a straight line. So sorry, which is a straight line like this. So what it is, it is a tooling axis. So when I see from the top view, the tooling axis might looks like a point. Okay, so in this case what is happening, I put a normal view of this tooling axis, and what it is doing, it is covering all the draft faces. So this is here you can see this is my part, and these are the slanted walls, these are my draft faces. And whenever you are making a normal view of your tooling axis, what you can see the all draft faces. So in that way your tooling axis is correct. Okay, so that is a simple process, that is a thumb rule that you should keep in your mind. And okay, up to this, these are fine. About knowing up to this is fine for tooling axis. Okay, there are plenty of methods that are available. We can, there is no any direct feature for making the tooling axis. So sometimes we can draw a sketch separately. Sometimes we can use reference geometries like points and lines. Sometimes we use a bisecting line, and sometimes we use extractions or intersections. Okay, by using all the features we have to develop a tooling axis, which is not a by default feature of any software. Okay, hope you guys very clear about tooling axis. Okay, next video we will try to do a tooling, we will try to create a tooling axis from the software itself. Okay, so now let's talk about the question. So why it is design requirement even though you are not designing the core and cavity of the part? So for example, so what the question means, so you are making this inner part only, but the tooling axis is more related to the core and cavity designer. So why it is required, why it is important to you to keep this drafting angle, the tooling axis? See, for example, this is your part. So in this way, the core and cavity designer can make a specially prepared core and cavity for this. So imagine if you made a part, okay, you have a requirement like this and you made a part like this, or else, okay, okay, in really you won't see the part like that. Okay, let's say you have straight walled part and you have asked, imagine these are the straight walls, so I can't able to draw that much precisely. Okay, imagine this is the straight walled plastic part, and straight walled plastic part you are asked a core and cavity injection molding uh, supplier to make this part. So what will happens, he will design a core and cavity. Okay, so you know how the injection molding process will works, right? So when the core is in a stable position and you will be having a cavity of your part here, and the upper cavity is moving, what will happens, if it is a straight walls, after the solidification of plastic part, the plastic material will stick to these walls, and it will take more time, or it will take more ejection force, right? So in order to overcome all these problems, we are giving the draft phases. Another question, okay, so the question, coming to the question, it is not design requirement of our plastic product designer, even though you are considering it as a design requirement. It is because you shouldn't make a part like you shouldn't make a part that cannot be manufactured by injection molding process. Okay, so by keeping the tooling axis from very beginning state of your designing or modeling, so it may facilitate the core and cavity designer to select or to design a suitable core and cavity, right? So that's it guys, that's up to this video. So hope you guys are very clear about the doubts and the concept. Okay, okay, apart from this, I just want to explain you something also. See, while we are doing a closed body, that means where I told you how the, see, for example, you will be given when you are doing a, okay, plastic product design. So most probably you will be having one class A surface. Okay, out of that you will be designing a class C. Okay, and I told you we have to design the class C surface also, right? The class C is nothing but the surface which connects A surface with B. Okay, so whenever your draft, okay, you are specified tooling exists like this, and you are given this class C surface like this way. So actually this product will not going to be manufacturable. Okay, why? Because these are the undercuts, these are the negative draft angle. Okay, that's why for the reference purpose also we are using, we have to specify the tooling axis. So from the tooling axis, there is a feature in the CATIA. So with a draft, with reference to the draft angle, we can create one draft face which is at a particular angle from this draft angle. Okay, and that is all about the tooling axis guys. So next video we will be seeing we will be seeing how can we create a tooling axis in CATIA. Okay, so then after whenever we talking about a BAW, we will create a, okay, that BAW also having the designer requirement of tooling axis. So whenever we are discussing about BAW, we will be talking about NXCAD also. Okay, that's up to this video guys. Thanks for watching, and if you find anything helpful in this video, please do subscribe to our channel, and have a good day.